remainder of these questions here, though, you're going to learn what this equation actually looks like, what the equation of this graph in F looks like today. That's what you're going to do after you have some time to work on some homework. But for that graph, again, there should be some arrowheads here. That's my bad. I'll make sure that that's on the test. And if ever it wasn't and you did this, and then told me the upper and lower boundary, I wouldn't be able to mark that wrong if I didn't have the arrowheads on there. So sometimes that's what I'm getting at. Like, formatives are good for you to see what's on the test, but it's also good for me to catch little mistakes. Like if I did that on a formative and then I caught it on the formative, I would fix it for the summative. So it's beneficial for me to write formatives as well, right? So let's assuming, because this does in theory go on forever, we could state the domain of this. Right? Doesn't look like there's ever going to be a restriction on that domain, those x values. Right? So right off the bat, you get to say x is a part of the real numbers. Okay, it goes on forever. Now the range, you just look at it and you go, okay, what value of y does it never go below? Never goes below 0, so the range, it can take on any value of y such that y is greater than or equal to 0. Okay, just has to be bigger than 0. This question here, I don't necessarily need to do G with you because you already did it yesterday. It's just the top question. It's a series of points. You just list the x values, list the y values, no repeats. Okay, that's the same. So you could list out whatever from that mapping, the mapping diagram. You could list the points and then just state the x values and the y values like you did in A, B, and C. Okay. Now, just before I leave, okay, I'll run you through at least, well, I'll show you how to do this in homework, okay, when you get to it. All right, if you ever proposed just an equation and not a graph, okay. By the end of the course, I think we'll be able to actually look at what that looks like without the use of Desmos. Same as this, for sure that one. But my hope is to be able to get you to the position where you could find that one as well. So this A should look very familiar to you because we spent 20 minutes looking at questions and they might still be on the board of what that is. What is that first equation or function? I know it's a function. What is it? It's a line. And if you go back to what we just said here, any line, as long as it's not vertical, will go on and actually has arrowheads. It doesn't have any restrictions or boundaries, I suppose. Like H, we know that the domain for this graph, because it doesn't tell us any restrictions, we can plug in any value of x and get any value of y. So there are no restrictions on its domain and range. So you're going to state that the domain is going to be xer. It can take on any value of the real numbers. And then the range alrighty, that's just recognition. Okay, we already talked about that one. This one here, if I were to like go onto my Desmos, which is if you do get this in the homework today, just pull up Desmos, try and produce the graph, and then just tell me what the domain and range are. That's going to kind of be the activity for today, is like, what do some of these graphs look like? So I'll just model that for you. If I jump over to Desmos here, and we click Graphing Calculator, in case some of you haven't used it before, you could just type in the equation that it's asked you to type in. So -3 x plus 1, that's 2, plus 6. So there's your graph. A little different than the one we saw earlier. And now we can stare at that and go, maybe I'll try and shrink this so you do both these at the same time. You can look at that and go, okay, what's my range going to be, or what's my domain going to be? A parabola, we already said what? What's the domain for a parabola? Can I put any boundaries on a parabola? Not in the domain, right? So I know right off the bat, the domain for a parabola, oh my goodness, I'm getting I got to really try hard to draw those things. Okay? No restrictions on the domain, but what's the catch this time based on looking at the picture? What's the range going to be? Can still get a whole bunch of real value entries for the range. So I'm still going to write YER. Y is a part of the real numbers, but you have a condition. The condition is, and be careful with how you draw the inequality this time. Y has to be less than or equal to what value? Well, it looks like if I go to my graph there, has to be less than 6, right? Everybody happy? Okay. And again, I'll let everybody get caught up here before I jump on here, but for the last one, this has a particular look. Now, the domain you'd probably be able to figure out by like plugging into your calculator if this was a test situation. Can you square root a negative number? You can't. You can't square root a negative number, right? Which must mean I can only plug in a value of x or bigger or less than 2. This is a little tricky of a question. If I plug in 2, I get the square root of 0, no harm, no foul. I can do that. If I plug in 3, what's the issue? I get the square root of a negative number now. That's not allowed. So there's your boundary, right? We have to plug in values that are less than or equal to 2 in order for that to exist, right? So the domain, nothing else really changes. You can say it can be any value of x. It just has a boundary on it. You just can't have any value bigger than 2, right? So it's XER such that x has to be less than or equal to 2. Alrighty, now for the range, oh, sorry, you guys can't see. There you go. Okay, for the range, you don't know what the range looks like, and then I don't necessarily expect you to know what the range looks like unless you actually plotted points and figured out what its y values were, right? So this would be an instance where it's okay to go type into Desmos. This is where you're at. Go to Desmos, type in that equation, and figure out what do its y values look like, right? Before you're actually writing out the range. Well, if I plug in, yes, sorry, question? Oh, what the answer is?
Yeah, we're asking.
Oh, what's the, okay, go ahead, yes, sorry.
That y is over 0.
Is it always, so if y was always 0, that would be like a horizontal line here.
Y is over 0.
Over 0, okay, good. I don't necessarily, so,
Yeah, this, if it's less than, the square root has to be like greater than, or like the result of that function has to be like the square root of 0 or higher, right? Which would be 0, like anything above 0.
yeah, okay, that's good. So you deduce that, right? That one's kind of a nice one to be able to like figure that out. What my next statement there was going to be, if I can plug in a whole bunch, like if I'm trying to figure out the range here, what to write down. If I can plug in a bunch of x values, like they're part of the real numbers, then I'm going to get a whole bunch of outputs that are also a part of the real numbers, right? So I know I'm going to be able to write YER. You were all just a little bit ahead of me in terms of like knowing that this has to be greater than 0, because the square root of 0, then it's going to turn into the square root of 1, square root of 2, square root of 3. It's always going to be positive, right? So it has to be y is greater than or equal to 0. Now, did I expect you to know that? No, I was going to go jump over to Desmos and show you what that looked like. How about I hit stop there on the video?